Okay, so today we're going to do two things. We are going to learn how to do pass parameters. And the two ways we're going to learn how to pass parameters is we'll learn how to pass parameters when the actual parameter is a global. And then we will learn how to pass parameters when the actual parameter is a local. So we'll see that there's done two different ways. In both cases, it's going to be call by value. I should say that, well, never mind. So let's proceed. Okay, so here's how to call a void function in C++. Remember, there's actually four things that you call. There's four things you do when you call a function. Do you remember what the four things that have to happen?
Storage for the return
Storage for the return value.
Parameters.
Return address. Storage for the local variables. So if it's void, which one does it not have?
The first one.
The first one. So there's only three things to do when you call a void. Are you with me? And they are listed here on this slide. You push the actual parameters, you push the return address, and you push storage for the local variables. Okay? So now the way the compiler does this, the way the compiler translates this to assembly language is it has to generate code, explicit code to do this. This happens implicitly when you write a program in C++. The compiler has to generate statements to do each one of these things explicitly. Now we already know how it pushes the return address, which instruction in PEP8 assembly language pushes the return address. We learned that last time.
Call.
That's the call. Okay. But now we'll have to learn how. We're going to have to learn how to do the push the actual parameters, and storage for the locals in this one. Okay. So now think about this. There's going to be a main program, and this main program is going to call a function. Yeah? Now, where do you think the code is in this sequence to push the actual parameters? Is the code going to be to push the actual parameters? Who's going to push the actual parameters? Is the main program going to push the actual parameters, or is the function going to push the actual parameters?
Main function?
Yeah, main will. That's correct. So do you see that that's the calling. The main is the calling function. So the calling function will push the actual parameter. Now who's going to push the return address? The calling or the called?
Called. Ling.
The called ling? Which state?
Doesn't calling it push the return address?
Yeah, so who executes the call instruction?
The main.
The main does.
So the calling.
So the calling does that. Okay, and then what happens when you get up to, but then what happens right after that statement? What happens? Where are you?
You're in the function.
You're in the function. So whose responsibility is it to push storage for the local variables? That happens in the function. That's the calling.
Called.
Sorry, called. Yeah. Okay. And then what happens in the reverse?
The function is on
When you get to the end of the function has to do what? Deallocates its local. And who pops the return address?
the function.
The function does, because that's where the ret instruction is. And then when you get back to the main program, you have to do what?
You have to add the...
You have to deallocate the
return address. Or the
the parameter. So who does that?
main.
The main. Okay, so here it is. Here's a summary of what you just told me. The calling function pushes the actual parameters, and it does that by executing sub SP. The calling pushes the return address by executing call. So does all this make sense?
Mm-hmm.
And then the called allocates the local variables by executing sub SP. This all just makes sense, doesn't it? It's all straightforward. And then the called executes its body. And then when it gets to the end, it deallocates the local variables and pops the return address. We said actually that there was that ret n instruction could do both. Remember, it was a double duty instruction. Okay? And then when it gets back, and then at that point, control has returned back to the statement after the call in the calling function. And so at that point, that's where the code belongs. The compiler has to generate code there to pop the actual parameters, and the way it does that is by executing add_sp. Are you with me? Now, do you remember in C++, there's several different ways to pass a parameter? And do you remember the difference between, I'm sure you do. Yeah, you can do call by value, and you can do call by reference. Okay, so our job is to figure out how, or is to learn how the C++ compiler actually does that. Are you with me? Okay, so the first example that we will look at is call by value with global variables. Okay, and I think with these concepts that we've already gone over, I think we'll be able to actually do a translation. So there's going to be a lot of let's do this. Well, let's do a translation and see if we can all come up with how to translate it, and then we'll see if we're right when we reveal the actual translation. Okay, so in call by value with global variables, what you do is, how do you access a global variable? Remember, first of all, how do you allocate a global variable?
You just put it in the spot
location.
memory.
Block.
Dot block.
Yeah.
Dot block, that reserves this fixed location in memory for it, right? And then how does main access that? Direct with a symbol, but with direct addressing, okay? And then how does it push that value onto the stack? Remember, stack relative, and remember it has to be like minus.
For local?
For pushing the parameter.
Okay.
Are you with me? For pushing the parameter, yeah? And then, once you're up there in the function, how does the function access it?
Isn't stack relative?
Using-
It has a name for it at that point. It has a symbol.
Yes, and the symbol, yeah, and there's going to be a different symbol for, it's going to be a different symbol for the actual parameter and for the formal parameter. Well, actually, there won't be a symbol for the actual, because it will be its value. It will be a negative, well, let's just do it.
We'll find-
Let's just do it. Oh, question?
Can I ask a C++ question?
Sure.
So when we were doing C++, we learned that main comes at the end
Mm-hmm.
a lot of times, and is that because of this? Because does this go back to assembly language? Like you want the symbols that you're going to be calling, the functions you're going to be calling to go before main calls them?
That's true in C++, that if you don't have main at the, well, I mean, you remember in C++ you have to have a forward reference. If you have a function before you define it, then you have to have a forward reference for
Yeah.
it, for the compiler. Now, because the compiler, the C++ compiler wants that forward reference so that it can do the translation from the beginning of the source all the way down to the end in one pass.
Okay.
Now, the assembler, our assembler with symbols, does not have that restriction.
Oh, okay. So
Notice that when we say branch to main,
it jumps.
the assembler, when it sees that branch to main, it doesn't know where main is yet because it just got that. You see what I mean?
Sense.
It did. So the assembler is a little bit more free, yeah, to use symbols that haven't been defined yet. So what it does is it makes one pass, so what it has to do is it has to go all the way through, and then after it goes all the way through, then it goes back and fills in the, and fills in the ones that it didn't know the first time through. Are you with me? So it has to make actually two passes through the source somehow. Now, fortunately for you, in your project doesn't use symbols. But you think about it. Like I say, we've had students in here who have done symbol tables just on their own when they got all excited about the project. But what you would have to do is you would have to think about how to do that, and then you would have to actually automate. You'd have to program that. You see what I mean? You'd have a symbol table. So every time you get a symbol, you'd have to put it in a symbol table, and then you'd have to be able to count and check, and then check to see if that symbol has been defined, used without being defined, and then that would be an error. Are you with me? But it's quite doable at your, I mean, you should be able, you could do it. You could do that. But that is an interesting difference between C++ and assembly language, because C++, if you're going to refer to a function before you, before you define it, then you need a forward reference, a forward declaration. Okay, here we go. And by the way, here we have the function first in C++. Are you with me?
Have
That's
to.
how it always is.
Well, I just got through saying, if you don't do that, what do you need?
Yes.
A forward declaration.
Yeah.
Yeah, okay. Is everybody good? Okay, so now check this out, sports fans. What do we have here? We have int num points, int value, int j. Yeah? And those are what kind of variables?
Global.
Globals, because they're outside main, yeah? Outside any function. And then, they're all ints, and then we have void print bar, yeah? Int n. And so what is that n? Actual parameter or formal parameter?
Formal.
That's the formal. And then int k, what kind of variable is that?
Local.
That's local to print bar. Are you with me? Then we have for k gets 1, k less than or equal to a, k plus plus, c out asterisk, and then at the end of the loop, c out n line. So what this does is this, whatever n you give it, it prints out that many asterisks on a line and then goes to the start of the next line. Are you with me? And then what does main do? Main does cin what? Num points, okay. And what is num points? Oh, that's global. All right. And then for j, what's j? That's another one of our globals. For j gets 1, j less than or equal to num points, j plus plus. And then what does it do? So the first we assume that the first number in the input stream is how many points follow, how many numbers follow. Are you with me? And then it loops through that many times, right? And each time it gets another value, it gets value, and then it calls print bar with value. And so when it goes up to that print bar, it'll print that many asterisks. So it's like a bar chart. Are you with me? Okay. And then return 0. Okay, so are you ready to start? Here we go. What's the first one?
Branch main. We should go around the room.
Well, I was thinking about that, but we're videoing this. I was thinking maybe,
Okay.
yeah, we normally like to go around one at a time, put you on the spot. But anyway, we won't put you on the spot this time. Okay, so, but maybe we should go around that room. Have you guys out there in the future do a little time travel and come back and tell us what we should be putting on the board here. Okay, so branch to main. Now, how do we do globals?
Dot block.
Yeah, so now the first, but now what's our first global?
Num point.
Num point.
Num points. So, num points colon dot block what?
Two. It's an integer.
2, and that's
Hashtag.
blah, 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 blah,
Pound 2D.
global variable,
Pound 2D.
pound 2D. Okay, next,
Value.
Top block 2.
dot block 2,
Pound 2D.
pound 2D. Okay, next one,
J.
J.
Dot block.
J. Dot block 2, blah, 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 pound 2D. Are we good? Okay, now what comes next here?
Print bar.
Print bar. Actually, before we put the print bar,
Do we want to call?
well, no, the code here is
Oh,
going to
we
be,
haven't gotten to main yet.
we haven't gotten to main yet, but the code here, but let's think about what print bar is going to be. Well, maybe, I'll tell you what, let's do. Let's skip over here. Let's skip over here and do main up here. Okay? And then when we get to main, when we get to the place where it calls it, then we'll sort of go fill in. Okay? So here's main. So now do we have to allocate anything here? Do we have to do sub SP?
Nope.
No, why not? Because those are globals. Okay, so
CN, so character range, but.
Carrie,
No, it's Dusty.
Oh,
Desi,
Yeah, that's a number.
so Desi what?
Num points.
Num points. Direct.
Num points, direct, okay?
get,
No, we need to
J.
load the accumulator with
yes,
one.
on J. So yeah, load
Load accumulator with what?
One.
1.
Why 1?
Because we have to store 1 to J.
Oh, I see.
Yes.
Okay, so load accumulator 1, addressing, immediate,
Store
accumulator.
J direct.
store accumulator, J, direct. Okay, are we good?
Yep.
Now see.
Now we need to do a test.
Now we need to do the test. So what's the test?
Compare.
Compare.
And this is the, now that we're doing the test, is this the 4? Okay, now I see there's another 4 up there, yeah?
So let's call this one 4 2.
Let's call this one 4, 2.
Okay.
Okay,
So,
compare accumulator,
yeah,
Num points.
num points.
num points,
So branch if less than, is
and
that right? Greater than?
Branch is greater than.
y greater than?
Because it's J is less than.
J less than or
num
equal to num points.
Less than or equal to. So it's branch if, so the opposite of branch, wait, greater than. You say the test is, what did you say the test was?
Less than equal to.
Less than equal to, so the opposite of that is greater than. Is everybody clear on this?
J is less than or equal to num points.
Yes.
You load it.
To what?
So you do the opposite.
Yeah, and.
To end 4, 2. Are we good? Okay, now what?
Otherwise,
Deci.
Otherwise, deci, now it's starting to get interesting.
Value.
value,
Otherwise, deci,
Value.
value,
direct.
direct. Now what? Now what's the statement?
Call print.
Oh.
Now what is it? Now is
Now you
it,
have to store accumulator.
okay, now, actually, we're gonna have to come over here, I think.
This is where we're going.
This is where, yeah. Now look, you guys, over here, at this fixed location in memory, we have num points, value, and j, right? Num points, value, and j. And so these are over here in a fixed location in memory. But now what are we doing?
Now we're switching to stack.
Now well, now we have to do call by value, right? And so where is, you know, what is our stack going to look like here?
We're going to have to push the parameters.
Well, yeah, we're going to have to push the parameter. So here, so where is the stack pointer at the beginning? The stack pointer is here. Are you with me? And what we need to do is we need to push that parameter up to the runtime stack. Now, how do we get that up there? And because what is the parameter? The parameter is what?
The parameter is value. It's a global.
Yeah.
The value. Okay, so now so we need to get, so what we need to do is I hate to say this, but we need to get the value of value.
And to do that, do we load
We need,
accumulator?
yeah, we need to get the value of value, and we need to put it here. Is everybody,
So we need a sub SP.
well, but before we do a sub SP, remember how we did that with the example? We did them with negatives.
Right. Okay.
So we have to load
All right.
the accumulator.
You have to load it
So-
at negative 1 or negative 2.
And then store it.
Yeah. So now, so let's go over here. So let's go over here.
So now
And
we
what,
load the accumulator.
okay, and so here we're gonna do load accumulator with what?
Value.
Value
Direct.
direct. Okay, so that's gonna put the value of value in here. And then what?
Store accumulator.
And then store accumulator.
Value.
But now, no.
Oh, yeah, negative 2.
No, store accumulator what?
Negative.
-2 addressing mode?
Yes.
Relative.
Oh, yes. Right? Now, does everybody see over here that that's going to put the value of value into here? All right? But now, how do we get this, now how do we take this SP
Now you sub.
and move this SP from here up to here? How do we do that?
Sub SP.
How much? 2. So here we do sub SP to
Immediate.
immediate. Now, does everybody see how that did that?
And then do we need a trace tag there?
We do, Because sub SP is, we need a trace tag, is right, good observation. And remember what do you know?
We're pushing a parameter.
Allocated.
Pushing back.
Yeah, so we're allocating, or pushing, I forget what,
We're pushing pound.
okay. So push, pound, value. No, wait.
We normally put this.
No, yeah, hold on. Yeah, hold on, hold on. Now what's gonna happen is,
Oh, we need the formal.
yeah, what's gonna happen is, this label that we want on this trace is going to be it needs to be the formal parameter. So what is the formal parameter that corresponds to value?
N.
N. So what yeah, this is a little tricky. So what we're gonna do is
Pound N.
pound N. Now, the thing of it is that we haven't defined what N is yet, the symbol for N is, because we said we're going to skip over that,
Oh.
okay? But we'll get to that in a minute. In fact, we're going to get to it right now. And now, after we do sub SP,
Can we call?
we call, okay? So now when we say, but now what do we call?
Print bar.
We call print bar.
And that pushes the return.
And that pushes the return address. So we'll call print bar. And over here, print bar moves this SP up 2 more. Remember, it always moves SP up 2 more, right? So now that moves SP, well, and actually it pushes the return address onto the runtime stack. So this is ret ADDR, return address. And this one, what did we say this one was going to be? N? Okay, so now we're here. Okay. But now the next instruction to execute is going to be what?
The print bar.
The print bar. So let's go over here and see what we have for print bar. But now, here's the thing, you guys. Print bar, now comes something interesting. We got a bunch of symbols because look, what does print bar going to refer to? Look at the code for print bar in figure 6.21. What variables does it refer to?
K and N.
K and N. Now, how does it refer to K? K is what kind of a why does it refer?
Local.
Because K is a local. How does it refer to N? How can it refer to N? Because N is a parameter. Okay, but what's going to happen is N and K are both going to be on the runtime stack. So over here, what you have to do is you have to anticipate what the runtime stack's going to look like. Okay? Because when we're actually executing the statements in the function, SP is going to be up here. Are you with me? After we do sub SP to allocate the local. So what's going to happen is, I'll just do it again. Here. So SP is going to be up here. And furthermore, what's going to be here? This will be storage for the local, right? Now what's the local?
K.
That's K. So now here's what we have to do. Here's what we have to do to figure this out. We gotta for this, for K and for N, we have to calculate what is going to be the offset from the stack pointer when the stack pointer is at the top of the stack here. So what's the offset for K?
It's just the very next one. So
No.
Don't equate 0.
0.
Zero. Right.
Yeah? So this is going to be 0, and so this is going to be 0. The return address, so this is 0, 1, 2, 3, and then 4 is the N. So the offset, so this is the offset. Offset of K is 0, the offset of N is 4. And yeah? So these are the equates. So what we do is we equate these identifiers for the purposes of coding the function to these offsets when the stack pointer will be here. All right? So let me see. So here, let's do, and we'll do the, now here's the coding, the styling convention. The style convention is that we'll do them in the order that we encounter them. So what's the order that we encounter them? First N and then K. All right. So n, so what we'll have here is n will be what? Dot equate. Oops. You said 4 and it made me write 4. Okay. So dot equate 4. Okay. And now,
Okay.
Formal parameter, pound 2.
and this is formal parameter, and that's a pound 2D, right? Are you with me? Is everybody clear? And then what?
Okay.
K, and that is what?
Dot equate 0.
Dot equate 0, and that's, but that's not a formal parameter, that's a what?
Local variable.
Local variable, which is, and pound 2D, right? That's how we want it to be displayed. And now what? Now comes the first executable statement of the function. So, because over here we did call print bar, now we have to have the symbol over here of print bar. So print bar is it. Now, what's the very first statement that has to execute in print bar?
Load the accumulator.
Nope.
Oh, we have to
Branch?
Nope.
sub SP.
Yeah, because remember over here, at this point the stack pointer is here, so we got to allocate storage for the so this is that part, allocate storage for the locals.
Yes.
So how do you allocate storage for the locals?
So
You do sub SP 2, and this is allocate, and what are we allocating?
and N? K.
K.
Yes.
Allocate local K, yeah? Does everybody see how that works?
Did you got immediate?
Yeah.
Sub SP2.
Oh, sub S2, you're right.
You-
Yeah, definitely. Sub S2 immediate. Yes.
Now we can load the accumulator.
All right. So now let's come over here. So now what has happened is SP is no longer here. Now SP is here. And now these offsets apply,
accurate.
accurately. Yeah. Now does everybody see how that recipe works? Okay. So now let's do the code for print bar. So what do we have to do first?
Load the accumulator.
Yeah, what are we doing?
We're setting.
We're setting K to 1. So how do you set K to 1? So now check this out. So load accumulator 1 immediate, and now how do you set K to that?
Store accumulator.
Store accumulator
K. Stack relative.
K stack relative. Now, does everybody see how that we're translating? All right? Okay, because K is right there. Okay, we're setting it to 1. Oh yeah? Okay, and then what?
4-1. Or first
Now we have to do, now starts our test. So we'll label this 4-1.
compare.
Do you want to, assume, what am I trying to say? Do you want to optimize?
We should load the accumulator with K again? Is that what you're saying?
Yeah.
But don't you do that at the end of your for loop? 'Cause we're not-
Yeah, so you want to optimize? That's what I'm asking. Shall we optimize? Okay, so compare accumulator. Yeah, but we had to look ahead and see, K is going to, okay. Compare accumulator and
Stack relative.
stack relative, and then what?
Now we branch if greater than.
Yes.
Because it's less than or equal to, so branch if greater than
To end for
to end for 1. Okay, then what?
Carry.
Decim.
Carry.
Deci.
Carry. It's a
Wait, I'm here, I have a conflict here. Deci or
character.
Oh, sorry. Yeah, she's right. Paragraph.
character output?
That's his back.
Okay, caro, and what is it?
Star.
Star.
Star,
Immediate.
a quote star immediate, because that's a single character, ASCII character.
We have to load accumulator.
With K.
With K, stack relative,
And then add
add accumulator,
one immediate,
1 immediate. Is everybody following this all right?
and
Store accumulator.
And then store accumulator, K, stack relative.
and branch.
And then branch.
And then branch to
For one,
4-1.
Unconditional.
unconditional,
for one direct.
4-1. No, just 4-1.
Oh, that's right. Okay.
It would actually be immediate if you wanted to put it in there, but, okay. And now we have,
We have a character.
we have an end 4-1, right? So end 4-1. I didn't plan ahead, and so we're having to write a little small here. Have you seen that? Have you seen that classic little thing? Have you seen that classic thing? Plan ahead, and it's way over on the right, and it's plan ahead, and the head doesn't. Anyway. Okay, and now, okay, oh shoot.
You do have to add SP, but we also want to do something else.
Yeah,
Character out.
Character
yeah.
output.
oh yeah, we do. Oh shoot. I didn't plan ahead. I just talked about planning ahead. Okay, so end 4-1, and then, what did you say, Caro? Caro,
You're on no.
bash in, immediate,
You're on no.
Caro.
Now we.
And now, you got this down here?
Ret 2.
And now you guys, yeah, now we do, oh no,
Ret 2.
oh yes, yes.
Do we add SP first, or do we?
But that doesn't.
No, see, Ret 2 does that.
Right, but doesn't it only do it for 2 and we have 4?
No.
Or-
Oh, that was a very good question. Let's come over here and answer that question.
'Cause don't we only.
Okay, look, at this point, Ret 2 adds 2 to the stack pointer to here, then it takes whatever is here and it puts that in the program counter, and then it adds 2 and makes the stack pointer be here. So that's why we only need Ret 2, because the 2 only applies to the locals.
Okay. And it will automatically.
It will automatically do another 2
For the return.
for the return address. That was a good point. Does everybody see why that's Ret 2 and not Ret 4?
Yes.
Because 2, there's 2 bytes of worth of local variables. Are you with me? And phew, I don't have to write another one, because this is the last one.
Add SP.
That doesn't.
No,
Talk about.
no.
Oh, Ret 2 does it. That's okay.
Yeah,
So that pops.
okay. So now, after this executes, where will SP will be?
On the end.
Yeah, SP will actually be here. SP will be back here. And so, and where will we come? We'll come to after the call.
I'm sorry, I missed. How did we go down 4 on the stack?
Okay, let's go over here again. Okay, so Ret 2 adds 2.
Right.
Then it takes whatever SP is pointing to on the stack, and it puts these 2 bytes into the program counter, and then it does 2 more.
Oh,
So that's included in the ret. All right. So the number that you put after the ret is only the number of bytes of the locals. Now, is everybody good? And when we get back, we will be at this point, right? But now, what do we have to do here?
Add SP.
Add SP, because now we got to go, you know.
Yeah, oh, yeah.
Okay, so here is add SP to immediate. And now what are we doing?
We are popping pound in.
I don't remember if I use pop. I don't remember if I use allocate and deallocate or push and pop. I don't remember.
You just push and pop.
Do I? And then pound n, right? And then what does the program actually do after this?
Stop. We
No,
have to.
because we're in the middle of a for
We have
loop.
to increment J.
Oh, we have to increment j.
So we load.
So load accumulator what?
J.
J addressing
Direct.
direct.
And then we add accumulator.
Add accumulator
1.
1 immediate,
Story accumulator.
store accumulator,
Direct.
J
Direct.
direct, and then we can do what?
Branch.
Come up to this test. Branch to where?
4-2.
4-2.
Now.
Is everybody following this all right? Are you guys following this all right? Okay. And now we come up here, blah, 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 and eventually
That'll be greater than.
it'll be greater than, so, and we'll branch to end 4-2, so end 4-2 will be down here. End 4-2 will be here. And is there anything to do?
Stop.
We don't have to deallocate anything? No, because these are globals. So this would be stop. And then dot end, right? Don't have any messages or anything? All right, are you ready?
Yo.
See, we're right.
Drum roll.
Trace tags.
Boom.
That's not all of it.
Oh, shucks. Did we miss something?
No, I think it's 2 pages
That's
long.
just the.
Oh, that's not, yeah, but here, can you check me out to see if that is the same as what we did?
Oh, it matches up with our left side of the word.
Exactly.
Exactly.
Exactly?
Yeah, we ended right.
Man, we did the optimization the same way as
Oh, I don't
in
know
the
about
figure?
that. I was just saying that we ended with ret 2 and it also ended like at the bottom.
Oh, I see. Okay, now is this the same as over here?
Maybe.
Check it, double check. I don't want any errors to go out into the cyberspace.
I think we're missing a couple trace tags.
That's all.
Oh, yeah, we should. Oh, we should emphasize trace tags. Where did we miss the trace tags?
Call print bar.
Carl print bar.
Oh, do we put a trace tag on call print bar?
It's not a trace tag.
Push the return
It just says push for
Oh,
address.
yeah,
That's just a
That's not
comment.
but that's not a trace
It is
tag.
a-
There's no.
Yeah, you don't have to, actually, you don't, it will automatically say ret address, return address. You don't have to put ret address. It automatically
We
does
only
that.
change what it says if we have a pound, right?
On the ret 2, we need to deallocate though.
Oh, you're right, we do. We did miss a trace tag there.
Do we actually have to write deallocate?
Well, the word, you don't actually,
Is it a key word?
no,
Okay.
deallocate, no, that's just for your own documentation. The pound is the tag. That's what the assembler looks for.
So
Yeah.
you got anything you want before it?
Yeah.
Oh boy.
You can say, hey, how about we deallocate this here variable, pound. Deallocate,
Pumpkin.
pound K, is that what we're deallocating?
Pumpkin.
All right.
Also, aren't we pushing or popping the return address?
Well, yeah, but
Another thing you don't need.
that's not, you don't need it. I mean, it does it automatically. That was just, all right, are we good? Okay, question?
No, okay.
All right. Okay, and then here's a little picture, a little diagram, all right? Now, the next one is how to do call by value with local variables. All right, you guys, watch this. Do you see this? Okay, do you see this? So to push the actual parameter, you use load accumulator with stack relative addressing. Otherwise, everything's the same. So now, look at this example that we're going to do. Does this example look familiar?
Yes.
Same thing. With just locals.
Yeah. There's no globals.
In fact, what does it look like print bar?
It's the same.
It's the exact same print bar. Well, wait a minute. If the code for print bar in this example is the exact same C++ code as print bar for the previous example, what do you know about the code generated?
Exact same.
It has to be the same. Are you with me?
Yes.
It absolutely, positively must be the same print bar. So look. And so where was our print bar? Our print bar was from here on, actually here's where it started, kind of. Are you with me? From here on down, that's the same.
I have a question.
Yeah.
With the, if we were to do this with like forward declaration, would a compiler like look at that and then say, okay, this is where I'm going to put the actual assembly
The
implementation?
code, yeah, that's a good question. And the answer is, Not
So
necessarily.
it doesn't matter because branches can go anywhere where the calls.
Yeah, yeah, and the compiler might have its own way of, in fact, it might even place the code for the functions at a certain, using a certain scheme, layout scheme, regardless of how the function, where it is in the code, in the source program.
Okay.
Yeah. But is everybody clear, though, that all of this has to be the same, because it's the same code? Yeah?
Yeah.
This function has to work, whether that value got there from a local or from a global. Do you see how? So it has to process it the same way. So this all is the same. But now what about this part right here?
That's
It's
not.
gonna be different.
This is going to be
Doesn't have
different.
global anymore, yeah.
Oh yeah, these aren't going to be, yeah, these are, so what will this, so where will these be?
The main.
These
top of the
won't
main
be, yeah, these will be, yeah.
And they'll be,
Yeah, now, so, yeah, well, okay, well, I mean, when you're doing it, you can, you're right, but these are going to be up here. These are going to be up here, right?
and we're gonna have to,
And furthermore, they are going to be what kind of variables?
local.
They're going to be locals. So let's come over here, and let's
Restack.
re-look at what our setup is going to be, all right? Okay, now check this out. So when the compiler is coming through and it translates all this for print bar, and now when it gets to the start of main, what does it get to first? What does it scan first? Num points? So look, here's what it's going to look like. Here's the stack, and num points will be here. Are you with me? Num points will be here. Then what will happen?
Value.
Value will be here. Then what will happen?
J.
J will be here, right? And in order to get this stuff here, SP will start off here. We'll allocate by moving SP to where? Up to here. Are you with me?
Yes.
So now, what does that mean over here? What does that mean about this? These aren't going to be dot blocks 2. What are these going to be? Let's just use an eraser so I don't have to rewrite all this. These are going to be dot equates. But they're going to be dot equates in the order that we get to them. So num point. So instead of this being num points block 2, blah 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 blah, this will be what?
Dot equate.
Dot equate. Now, what is the yeah. Yeah, now here, because what's the address of J? The bytes, there's 2 bytes in each one of these, right? The addresses are 0, 1, 2, 3, 4, 5. So num points is going to be 4. Are you with me?
But we do change it by 6, right?
Right. And then value will dot equate what?
2.
2.
And then num point, J will dot equate what? Okay. But now, instead of having this be the first instruction in main being deci, now what does the first instruction in main have to be?
Sub SP.
Yeah. So now our main is here, and we will sub SP by 6 immediate, and we have to allocate now, yeah, in order.
All
Oh, yes.
on the same line.
Yes, yes.
In order.
In order.
So
Is it pound J first?
No.
Oh,
pound
No,
points,
pound num points.
pound value. Pound J.
Oh, so the order that they're being put on the stack.
Yes. Now, is everybody clear? And it's the same order as we list them here.
Would it get largely messed up if we changed?
It would, well, what would happen is your trace would mess, you'd have the wrong labels on the,
Oh, okay.
is everybody clear on how that works? And then, actually, this is going to be pretty easy, because now all we have to do is what?
Make a change. change the address mode.
Yeah, so now we deci num points, but now instead of D, what is it? S. Load accumulator 1, store accumulator J, what? S. Compare accumulator num, oh, we had a mistake here last time.
We didn't have an address.
Compare num points, this should have been before
That'd have been D.
D,
Or D.
And now it's S.
but now it's S. And then branch on greater than info, and then deci value
S.
S,
S.
S,
S.
S, I, print bar, add to immediate,
Which is,
S.
J, S.
Store accumulator S.
that was S.
This one's
Oh,
S?
that's fine.
No,
Store accumulator
Store.
J S.
Oh, store accumulator, J, S.
That's it.
All right, did we do it right?
Don't we have to change the dot equates on the N?
We have to add SP at the bottom.
Oh, and we have to add SP. Yeah.
Yeah.
Before the stop.
Yes. So, add SP. Is everybody clear on this?
Mm-hmm.
And then we have to do trace tags.
6 immediate.
Oh, 6 immediate.
Yes. Very cool.
And then we have to do trace tags.
Yeah.
Okay? Yeah.
Do we have to change the dot equates on the N and K to 6 and 4?
Oh, no, we shouldn't have to.
Or something.
I hope not, because that means that code would depend on,
Right.
No.
No.
because what's going to happen? Because look what's, actually, that's a good question. Because what's going to happen is when we actually make the call,
We do this.
this is going to be the,
That's so cool.
it is so cool. I'm glad you asked that. Let's draw it.
Okay.
Let's draw.
This, okay,
So we do
No,
the
that's-
call.
That's K.
That should be N.
No, that's N. That's N.
yeah, this is N,
Then the return
And then
address.
Return.
and this will be address, and then this will be what?
Okay.
K. And then at that point, SP will be here, and at that point, because we're referring to K and N, we're referring to everything on the runtime
You never have
stack.
to refer to
And you
it
never have to refer to the other ones.
because they're not in there.
Yeah, and in fact, what is this group of, do you remember what we called this?
Yeah. No, I don't remember. I remember having that box.
Yeah,
Is it like a block?
it's called a stack frame,
Or activation record.
or activation record. This is called a stack frame. This is the stack frame for main, also called activation record. Okay, so that's the stack frame for this. The stack frame for this is here. The stack frame for the function is that one.
And it draws the stack frames and update.
It bolds them. Yeah, is that slick? Isn't that a great user interface? I wish we had time, at the beginning of class next time we'll or maybe I could do it offline. Do you want to see the demo at the beginning of class next time? All right, of this, yeah. Yeah, it's easy, it'll only take a few minutes. Okay, we'll do it. But anyway, you'll see, it'll be really cool. We can do both examples. You know that help system, you can load the examples straight in, and then you can modify them. Yeah,
Tonight still work?
And
yeah.
Thursday.
Okay? So now your assignment for Thursday is to
Do one of these.
just to do one each.
Well, the same.
Oh, no, wait. The assignment for today is to do the
Tonight
first
is
one.
Void. This one.
Right, I'm sorry. And the one on,
No, it's void. It's just,
yeah, it's void.
switches from
It is void.
No.
But it's
Right.
globals. It's to do, yeah, but it's to do it with globals, and then the one on Thursday is locals.
Oh, is that all it is?
Yeah, that's, and it's the same program.
So this is tonight's homework.
the first example.
The first example one is like tonight, yeah.
Okay.
But look, they're so easy, once you
Yeah,
do
the
one,
transfer is
yeah.
great.
In fact, so what I recommend you do is, once you get tonight's homework done and you start working on your project. Now, what we're gonna do, because guess what, you guys? Monday, I think, is the
Yeah.
next big milestone. So we're gonna spend all day Thursday and probably all day Monday
Talking about the most.
talking about the project. Because, well, there's some more code that we have to go through. It'll only take about half the class time to get through the rest of the code for the project. But you need to be looking at that, and you need to be working on it.
So by Thursday, you said we should probably have our finance state machine implemented?
Yeah.
The one we had?
Yeah, the one you had, yeah. Okay, so are we good? Good deal? See you Thursday.